Mayya Alochi here, and in this video we will learn about Le Chatelier's principle and how to easily apply it to problems given to you by your professor or teacher. So Le Chatelier's principle states that if we have a system at equilibrium and this equilibrium is disturbed by a change, the change could be either temperature, pressure, or concentration, the system will shift in order for the equilibrium position to be re-established to counteract the effect of this disturbance. And I am going to teach you how to recognize where your system would shift. So there are three ways a system can be disturbed, and these are changes in concentrations, changes in temperature, or changes in pressure volume. And we will do this with examples. So let's say that I have 2A, and let's make my A gas, plus 3B, and let's make this liquid. And for this is my equilibrium arrow. We write two arrows, one forward, one backward. And let's say that this makes C, and let's say that this is gas. So the first thing we will talk about will be changes in concentration, and here we will look at this guide. So if my concentration is increasing, the equilibrium will shift to the opposite side of your substance. For example, if the concentration of A increases, or if I add more A, that means I have too much of it. So the equilibrium will shift to the opposite side. A is on the left, equilibrium will shift to the right, to the product side, so that A could get smaller and equilibrium could be reestablished. If my concentration decreases, then the equilibrium will shift to the same side. So if my A decreases, where does the equilibrium shift? To the same side, so it would shift to the left. Let's do this for C. If C increases, I shift to the opposite side. I will shift to the left. If C decreases, I shift to the same side. I will shift to the right. Now, it is really important to note that this is applicable only to aqueous and gaseous substances. So for example, if you see L, which stands for liquid, or if you see S, which stands for solid in your equation, adding or decreasing the amount of those substances will not shift the equilibrium. So this is only for gases if we see G, or aqueous substances if we see AQ. Next, let's talk about pressure and volume. So pressure and volume have opposite relationship. If my volume decreases, that means my pressure will increase. And if my volume would increase, my pressure would decrease. So if I know one, I will know the other. Let's deal with pressure. What happens if my pressure increases? If the pressure increases, we will shift to the side with less moles of gas. So we will only have to look at gaseous substances in our equation. For moles, we will look at the coefficients in our equation. So for example, let's go back here and let's just erase this, and let's look at what happens if our pressure decreases, for example. If our pressure increases. So let's look for our gaseous substances. On the left, my substance A is a gas because it has a G next to it. On the right, my substance C is a gas because it has a G next to it. This is liquid, so I will not take that into account. In terms of coefficient, there is a number 2 in front of A. So there are 2 moles of gas on the left, and there is 1 mole. If there is no coefficient, that means 1. There is 1 mole of gas on the right. If my pressure increases, again, I shift to the side with less moles of gas. So if my pressure increases, where would I shift? I would shift to the right because the right side has less moles of gas. So That's what happens if the pressure increases. If the pressure decreases, we will shift to the side with more moles of gas. So if the pressure would decrease, I would shift to, what side would I shift to? If the pressure decreases, I don't have enough gas, I need to shift to the side with more moles of gas, and that will be to the left side in this example. Gas creates pressure, so if I have too much pressure, I want to go to the side with less gas, and if I have too little pressure, I need to go to the side with more moles of gas. In terms of volume, it will be just opposite because pressure and volume has opposite relationship, but you can think of them whenever there is a change in volume, you can translate that to change in pressure, and then you can go from there. Let's go ahead and look at temperature. Temperature is another thing that will affect your equilibrium. So if your question mentions temperature, then the first thing that you must do for your equation is to figure out if your equation or if your reaction is exothermic or endothermic. Either in the question, you will be told that the reaction is exothermic or endothermic, or you will be given delta H. If your delta H is positive, that means your reaction is endothermic. And if your delta H is negative, that means your reaction is exothermic. So here I wrote, if delta H is positive, reaction is endothermic, you will add heat to the reactant side. If delta H is negative, that means your reaction is exothermic. It releases heat, and you will add heat to the product side. Let's go ahead and say that, for example, my delta H is equal to plus 50 kilojoules per mole, something like that. So now I know that my reaction is endothermic because this is positively charged. My delta H has a positive sign. And if it is endothermic, that means it is absorbing heat, and I will add heat to the reactant side. If my delta H was negative, that would mean that I have an exothermic reaction, and I would add heat to the product side. Next, you can deal with heat as the same way as one of the substances, either on the reactant side or on the product side, depending on your reaction, and you will deal with it the same way you would deal with concentration. So once you have established where your heat is located, if it increases, again, you shift to the opposite side away from heat, and if the temperature decreases, you will shift to the same side towards heat. So in our situation, for example, if it said the temperature increases, where would the equilibrium shift? It would shift to the opposite side. So it would shift to the right because my heat is on the left. We want to get rid of heat. If it said the temperature decreases, it would shift to the left. Equilibrium would shift to the left. So far we have talked about concentration, pressure, volume, and temperature. The next one is catalyst, and this is kind of a tricky question because a catalyst speeds up the reaction, it makes the reaction go faster, but it does not result in a shift of equilibrium. So if your teacher says catalyst was added, where does equilibrium shift? You will say no change, it does not shift. Another thing that your professor could talk about, but this is more unique, is addition of inert gas either at constant volume or at constant pressure. So this is just something for us to remember. If inert gas that's not a part of our equation is added at constant volume, equilibrium will not shift. And if inert gas at constant pressure is added to our equation, equilibrium will shift to the side with more moles of gas. This is Mayya, and I hope that you enjoyed this Le Chatelier's principle explanation.